All right, so vectors in a plane. These this is kind of like a combination of all so everything we learned about trig is gonna be applied here. The idea of a vector is saying, like, let's say you're going north and south. A vector is like how much north you're going compared to like how much east you're going. So if you're going north and east, there's this little dot right here, and this is an arrow that represents it. So the magnitude, how long this is, kind of talks to you about the what's it called? The intensity of it. So, for example, let's say you're going 2 miles an hour, 2 miles an hour north, and you're also going, I don't know, 5 miles an hour west. This kind of tells you how far you're going. The rotation kind of tells you what direction you're going. And the magnitude itself, how long this is, tells you your overall speed. So that's what a vector is. A vector is, you think of it as a point telling you how far you're going. And you can use trig to kind of help you figure out distance and things like that. So in this module, we're going to learn how to identify, add, and measure the magnitudes of vectors. So it shouldn't be too hard. Adding vectors, you can only add the x values together, you can only add the y values together. Measuring the magnitude, we're going to use a lot of Pythagorean Theorem, basically, is the way we get these done. So it shouldn't be anything new. We're just talking about it in a different way. So if we're starting at point P and going to point Q, this is our vector. Our vector is P to Q. And it's represented like this. P to Q with this little ray looking symbol, that's going to be our vector. This symbol with the double absolute value, it's not that we take the absolute value twice, that'd be redundant. Like if we say -3 absolute value and then we do it again, it's still going to be 3. This just means the magnitude. How long is this line as this vector? I don't know why they have the ray. Usually they don't have the ray, but in this case, I guess they include the ray. So when we're saying this, we're saying like, well, how fast are they going that way, for example? How fast are they going overall? We don't want to know how fast they're going this way and then how fast they're going this way. They're moving in one direction. And usually the location of that direction, we're going to say something like, I don't know, like 30 degrees, uh, 30 degrees north of east. So if this was 30 degrees and this way is east, we would be saying 30 degrees north of east. So like if you're ever like sailing and things like that, Navy, they use this a lot to kind of figure out the position of things and where they're going to be and how far they're going. All right. So the way we figure out the vector, I just think of it as using the Pythagorean theorem. It's a squared plus b squared equals c squared, or you can think of it as c equals the square root of a squared plus b squared. How do we figure out what our a is, though? So the way we figure out our a is we're going to take the x value of our qx minus p of x. So that's how we're going to figure out how long this is. They call it P1. I don't know why they don't call it X, because it's the X value, obviously. Then we're going to square that. So that's our A. In order to find out our B, we're going to take Q sub Y, it's the Y value of our Q, minus the Y value of our P sub Y. And we're going to do that. So that's how we get this formula right here. So that's how we end up solving for these. So when we're talking about the magnitude, we're just solving this. You can also figure out the magnitude by just adding the vectors together and squaring them. Um, that I think is like a weird way of symbolizing it. Like if you already kind of knew what this vector was, why do you need the help of everything else? So let's kind of get into it. So this is our a squared plus b squared. Oh, I see. They're saying this is the sum of two vectors. We have one vector going this way. So in this case, this is my vector A and my vector B. Oh my gosh. It's probably going really slow for you guys because that was going really slow for me. So I have a vector A and a vector B, and it's going to give me this vector right here. So that's what it means by adding two vectors together. If I have a vector going one way and I go this way, the resulting vector is the diagonal. Is this making sense so far, guys? So same thing with subtracting vectors. So if I were to subtract a vector, it would kind of look a little different. So in this case, I have a negative vector and I'm adding a positive vector. So I'm just going to square the vector. So you have to square it first. You can't just be like, I'm just going to add these two together. You have to find the magnitude of the vector first. So that's where you get this 25. This 12 comes from here. So we have to do those together. So you can't just add vectors willy-nilly when you want to find the magnitude. At least you cannot add the magnitude of vectors. Magnitude. You can add vectors together, that's fine. Like if you add vectors together, it will result in this vector. But you cannot add the magnitude of vectors. All right, so let's start with a problem. And it would help if I didn't have that solved out. So here's my vector. I have this vector here. I start off here and I go here. So if I want to figure out what this vector is, I need to subtract it out. I need to figure out how high did I go. Well, if I'm going from -4 to -5, I went down 1. And if I'm going from 11 to 4, I went down, what is that, 7? Yes, I went down 7. So my vector kind of looks like this. I'm going down 1 and I'm going to the left 7. So my resulting vector is going to be negative. I'm going to be going this way. Now, the thing about a vector, though, is its magnitude cannot be negative. You might have noticed that because we keep squaring everything. How can we have a negative vector if everything keeps getting squared? So your magnitude's never going to be negative. That's one of the reasons why they use absolute values. But the direction can't be negative. That's when we're going to start using degrees and stuff to measure. So my resulting vector is -7, -1. And if I wanted to find the magnitude of this, I'm just going to do a squared plus b squared, and I get square root of 50. So can't really do square root of 50 here. They don't really give us symbols to plug it in. So you can use any calculator you want. If you want to use their calculator, that's fine. Just remember you have to put 50 and then hit the square root button. I don't know how many decimal places they want. Oh, nearest hundredth. What do I get for not reading questions? Nearest hundredth. So 7.7 is what they want. So 7.07 and enter that. And that's all you have to do. So in order to find the vector, you have to figure out how much you moved. Another way of doing it is take your terminal point, your 4, take away your initial point. So I'm going to do 5 minus -4. That will also give you an answer. So always do your start off with the end and subtract your beginning, and that's going to give you an answer as well. Is this making sense so far, guys? Shouldn't be anything too crazy. So now we're going to deal with vector W. Oh, now I want chicken. That's going to sound so weird to everyone watching this on YouTube later. So now I'm going to subtract the 2. So my x value, if I have negative 4, take away 2, I get negative 6. So in other words, I went down 6. So this is negative 6. And then I'm going to do my y values next. So I go negative 2 minus 5. So I went to the left 7, which makes sense because if I start off at 5 and I go all the way to negative 2, I'm going to the left 7. So this is going to be negative 7. Now I want to find my magnitude. Well, luckily, since I have my vector, all I have to do is negative 6 squared plus negative 7 squared, and I'm going to take the square root of that. That's going to be 36 plus 49, and that's going to be, someone can check my math later. I want to say square root of 85. Well, I guess Edmentum can, because I'm just going to type it into here. So I'm going to do 85 square root, and they want it to the nearest hundredths again. So in this case, it's 9.22. 9.22. I'm going to enter a negative 7 here. I'm going to enter a negative 6 here. And let's see how good I did this. Perfect. So that's how you find a vector. Nothing too difficult. You guys can handle it. So again, you guys can I always recommend watching these on your own. They probably have a script when they do these. So this isn't even a video. It's literally just saying, wow. It literally just goes to the activity. All right. Whatever. So this is asking what happens when we add vectors together. Well, I kind of already answered that. You kind of move the same direction. So let's say I wanted to add u and v. The interesting part here is if they start off at the same point, all you have to do is just draw one tip to the other. That's all we're doing. So, oh wait, no, that's subtraction. I'm sorry, I always get those two mixed up. When we're subtracting vectors, we go from one tip to the other. When we're adding vectors, it's as if we're moving this whole vector right here, and we're going to move it here. And the ending result is going to be that u plus v vector. So think of it this way. I'm taking this v vector right here, and I'm moving it here. And this brand new vector that kind of feels like it came out of nowhere, that's our u plus v vector. So that's all we're doing. We're just, let's move one of the vectors, then let's move the other vector. That's all we're doing when we're adding vectors. That was vector multiplication. Multiplication, we'll just see it just makes the vector longer. So if I have these vectors together and I want to do vector subtraction, what I do is I move the amount of that vector, and then what I'm going to do is, wait, is this also, are we still adding vectors? We are still adding vectors. So you're going to do stuff like this. So your resulting vector will be here. So this is adding them. It just so happens that they're going in opposite directions. So this is still just a review on vector addition. Go on to the next one. This is what happens when we increase the magnitude of a vector. It just gets longer. And all you're doing is just multiplying each of the components. So when you're multiplying a vector, you're just multiplying the x value and the y value. And here's proof of that. They're like, well, let's see. It is 3 times longer. So by multiplying each of these little parts, you do that. So if this magnitude was 15, if we multiply it by 3, it becomes, or if this was 5, if we multiply it becomes 15. So this is just kind of a proof. It's saying that if we have, how can I put this? Well, I don't think there's any other way to explain it. By multiplying this by 3, it's negative 3 and 4. And it seems pretty obvious when you think about it. If you remember similarity triangles from geometry, if you multiply this by 3, you would get 9. And if you multiply this by 3, you would get 12. It's the same triangle. Like the angle is still going to be the same. It's just a lot longer. So this is going to be 3 times longer. So the blue line or the green line, oh no, the green line is 3 times shorter than the blue line. It's stuff we've already done in geometry, just now it's kind of this combination of geometry and algebra because we're using x and y coordinates. So that's what I've always thought about trig. It's always just the combination of the two, basically. So now what we're going to do here is if the initial point is 5 and negative and our terminal point is this, so we need to find our u vector. So our u vector is going to be, I didn't put my mask on my headphones, so my ears hurt right now. Give me a second, guys. Oh, much better. All right. So when we're doing this, we're going to do 8 minus 5. So our x value is 3. So that means we're going to go to the right 3. And if we're at negative 9, I'll use a different color. Negative 9, take away negative 7. This becomes negative 2. So our vector is 3 comma negative 2. So identify ones that would have that multiplication. So in other words, it wants it to have the same degree. So for example, it could go right 3 down 2. It could also go right 6 down 4. It could even go right 9 down 6. So let's take a look here. So we know, also keep in mind, we could do it negative too. So you want to make sure you're counting these correctly. So if I look at this, I'm going to go 1, 2, 3, 1, 2. So this is 3 to the left, 2 up, which is the same thing. We're just multiplying it by negative 1. So this is okay because we're just multiplying it by negative 1. I don't know if that's checking it or not. And then if we do this one, we're starting at 10 and we're going down to 2. Is that 2? So this is 8. So going from 10 to 8, that's 4 times. So is this 4 times as long? Yep. This is 4 times as long because we're going down 8 over 6. And I think that, 12. Down 8 over 12. And that was an option because, again, remember our vector was 3 comma negative 2. So if I multiply this by 4, I would get that. Let's take a look at this one. So this one, we're starting off at negative 1, and we're going all the way up to 13? 13. So there's really no way for us to get from negative 1 to 13. That's 14. 3 can't turn into 14, so that's not right. Let's take a look at this one. We're starting off at negative 2, and we're going up to 4. So that means we're going to go up 6. And if we're starting at negative 12 and we're stopping at negative 1, that means it's 11. So that can't be an answer because they don't have the same ratios. If we look at this one, we're starting off at negative 10, going up to 8. And we're going to go to the left, negative 2, all the way to 10. Also 8. Oh, wait, 12. Sorry, negative 2 going up to positive 8. So this one is a possibility because this is a negative. Wait, backwards. We're going left 12, up 8. So if we multiply it by negative 4, that's an answer. Looking at this one, we're starting off at negative 2, going all the way to 8. So we're going left 8, which doesn't make any sense because we should be moving by 3s. So this one's not an answer. Let's take a look at this one. We're moving from 3 to 3 to 10, which is moving by 8. 3 can't really turn into it, so I'm going to say no on that one. Here we're moving from 6, I believe it's 6, yep, 6 to 9, so we're moving 3, but we're moving up 2, which we should be moving down, so that can't be an answer. So I'm just going to submit what I have, and you guys could probably do this a lot better than me. My eyesight's a little off today. I don't know which ones I missed. So I'm just gonna show the answers. Weren't those the ones I picked? I think, I picked this. I think I might have accidentally picked this one. Oh my gosh, Edmentum, why do you hate me? And this one isn't it because we're going from 10 all the way to 8. So we're going down 8 over 12. I don't know. Edmentum's weird. All right. Well, here's the explanation. They're just saying that it's u. This is negative 4u. So just remember, main thing to learn here is that you can multiply by negative and positive numbers. Just keep track of your x's and y's. All right, going to the next one. All right, so you can also combine two vectors in various ways by multiplying and subtracting them. So just remember, always do your multiplication first before you do any other operation. So if you're multiplying a vector, you multiply your x's and y's, and then kind of distribute it. So for example, since this one's subtracting 3, we're going to multiply everything by negative 3. That's how you end up getting this positive 12, even though we have a negative 4 right there. So with any two vectors, you can basically get any plane as long as the vectors aren't the same line or parallel. As long as the vectors aren't parallel to each other, you can make an entire plane. And the reason for that is, let's say you had two vectors that were only a little off. If you start multiplying things by negative vectors and things like that, it can start covering the entire area depending on how you're doing it. I'm not sure if that makes sense, but it's just this idea of like, see how you can include all of this area in it. Well, if you multiply it a little bit more this way, you can include more area. I don't know if that really matters in this, but I just kind of wanted to point that out, that you can cover an entire plane just as long as your vectors aren't parallel. A scalar multiplication is just referring to one direction. So for example, an x value is a scalar, whereas a vector has two directions. It has a y and an x. So that's why you'll hear the word scalar a lot. A vector means two directions. All right, so let's kind of take a look at this. Vector addition and scalar multiplication. So if I have a v, and I want to describe my u, so vector u is up or right 2, down 5. Describe how you would use a graphic method to doing this. Write it down. So what I would do if I'm adding these together, yeah, I'm adding them together. I would say I would start at the terminal point of V of vector V. I don't want to draw that little line, so I'm just calling it vector V. I would start at this little tip and move right 2, down 5. Right 2, down 5. And then parentheses, I'm just going to say the components of vector U. The resulting vector is the sum of the two vectors. I'm basically just saying that by doing this, that ends up being the vectors added together. Let's see what they said. Draw the 3 units. Basically the same thing I did. They just worded it a lot different. All right. So now this is our vector. Describe how you would use graphical notation to add the vectors. All right, so again, this time it's at the end of U. So I would start at terminal meaning the end, terminal point of vector U, and move. It's a positive 3, so I would move right 3 units, and the y value is positive 1, and up 1 unit. Resulting vector would be the sum of the two. So that's how you basically just use graphing to do this. So they gave you two options here. They're like, oh, you could draw vector V and then do vector U. I'm like, you guys already drew it for me. You guys already drew U. I'm just gonna start there and move what it tells me to. They're like, oh, but you can also draw U. Where are we? I'm so lost now. Oh, here it is. I was like, where'd the answer go? And I'm like, oh, this is the answer. You can also draw V and then move U. But I'm like, if you already drew U for me, I'm just going to start there. So part 3, but you added in different order. How would you, oh, was I supposed to do it in a different order? Oh, yeah, I did do it in a different order because first I did this way. So, uh, what was different about them? Did they result in the same vector? They made the same vector. So it does not matter which vector you start off with. So it's basically just saying that you can start with your vector U, you can start with your vector V. Addition is, I believe it's called cumulative. Cumulative property, meaning that it doesn't matter which one you start with. So below we have half of V. So below we have vector V. Write the components for vector, or half of vector V. So if the x component is 6, we're going to cut that in half, and that's going to be 3. And if our y component is 4, we're going to cut that in half and do 2. So when we do this, it's like the components for half of vector v is, or I should say r, because they're components, proper English, of vector v are 3 comma 2. Put my greater than sign there, because we divided the components of vector v by 2. You can barely see where I wrote half, but I just didn't want to use the equation editor to do the little fraction button. You guys can if you want. It's probably better looking, to be honest. All right. Let's say, all right, so write the components for this. So I'm actually going to type this all out. So since the components of vector w are 2, we're going 2 to the right and 1 up, so 2 comma 1. Then the components of, what is it? Negative 2w? Negative 2w must be negative 4 comma negative 2, because we multiplied the components by negative 2. And submit it. You can see that they just literally show the work, so I'm getting way too fancy here. All right, so this one I will show the work because it's gonna be a while. It's gonna be a bit, so I'm just gonna copy and paste these here. So give me a second while I copy and paste this. Come on. I'm gonna copy it. Copy. Paste. Okay. There we go. And then what I'm going to do for the next one is I'm going to copy and paste these two because I am lazy. Control C. And you'll see why I want to copy and paste it right now. And then I'm going to do Control V. So instead of writing vector u, what I'm going to do here is I'm literally going to take vector u and I'm going to paste it here. So I'm going to highlight this and go Control V, and that literally gets rid of it. So now I want vector u, sorry. Now I want to replace vector v. So I'm going to highlight what is vector v, copy that, and I'm going to substitute it in. So I highlight this, paste it, v's gone, and it's replaced with that. And I'm going to do the same thing here. And one thing that you might have noticed is unfortunately it didn't save the enter. So I'll do that right now. I'll leave some spaces here so I can solve this first. So if I'm distributing this 2, it ends up being negative 2, comma, negative 2, comma, 0. And that's one thing you'll notice is even though there's changes here, because there's no change in y, there's still going to be no change in y. And then we're going to distribute that negative 2. So because we're distributing it, I'm going to put a plus sign because in the parentheses is now 0, comma, negative 6. So that's what's happening there is we end up adding it because this got distributed in. So it's already counting for that negative. Then this one, we're just going to add 4 4. All right, add those up. So negative 2 plus 0 plus 4 is going to result in a positive 2. 0 plus negative 6 is negative 6. Plus 4 is negative 2. So that's going to be our answer for the first vector. Let me grab this vector again to plug it in for u. In the next one, so I'll leave like one space there. Plug that in. So this is the whole reason why I copied and pasted it, so I can just substitute by copying and pasting. And I guess highlighting over would be part of it too. Copy W, paste. No, I accidentally hit Control C instead of Control V. Control C. I wonder if it would have been faster if I typed it out. The world may never know. 1 comma 0, because I'm distributing that negative, plus 0 comma 9 plus 8 comma 8. Add all of these together, so 1 plus 0 is 1 plus 8, that's going to be 9. 0 plus 9 is 0, 9 plus 8 is 17, and those should be our resulting vectors. Add those up. Let's see how it is compared to this. Spot on. So I'm going to give myself a 5 for this one. It was pretty simple, right? Does it make sense how I did it? It's basically just the algebra you guys are already used to. So that's all we're doing here is just plugging stuff in. The only difference is instead of plugging in one number, we're plugging in two numbers. That's the difference between a vector and a variable. So vectors, vectors and variables are very similar. And going into the next one, or I don't think we're gonna have enough time to finish, so let's leave off there for now. Oops, we'll go over that next time. So we'll go over this problem next time, unless you guys are like, I'm gonna look that up on YouTube. What's up? I want chicken nuggets. You should.